Yes. I have no fancy slides, but I hope my demo is good enough. So who here knows JavaScript? Good. OK. So if you just have like a nice hello world, which does not exist. One second. Thanks. So just a normal hello world, you can do it with Node or Bun or your preferred JS runtime. Or you can do it with Porffor, which is a new JS engine from scratch, which compiles JS to WebAssembly ahead of time, unlike existing JS engines, which either JIT compile or just interpret, which is good because then you can just do this, where you can just output a WASM binary. And it's just like 50 kilobytes, where there's some existing tools like Javi, which I do not use enough. But you can just also give it a JS file, and then it will give you a nice WASM binary. But this works by bundling an entire interpreter in WebAssembly. So the downside to that is the WASM binary is like 1 megabyte. And the other cool thing you can do with this is that since we control the entire compiler chain, you can also compile to native binaries, like this. So this works by, it compiles JS to WebAssembly and then to C with its own compiler, and then that gives that to Clang, which LLVMs, various things. So you can just run JS.
Yeah.
But the best part is this is a 20 kilobyte native binary. When there's some existing stuff like Dino, you can compile, which it just bundles this entire thing. But it works, which is nice. The only problem is the native binary is 100 megabytes. Which, like, obviously, it actually runs all JavaScript, which is nice. But there is a standard test suite for JavaScript called test262, which I run against every commit. And it currently passes over half the tests as of like last week.
Wow.
Just very nice. So you can do all sorts of fancy JS things like dates, or like more modern like functional things, like say you have an array. You can do like fancier, like say, oh, I want to sort this in reverse. And then also for each one, I want to console.log. And it just works.
Can it run WebAssembly?
Well, yeah, so I started this in my free time around a year and a half ago, but I'm working on it full time as of August. It's my day job, which is very cool. I have various experiments. One is a WASM engine written in JS. Oh yeah, I forgot to say, this entire compiler is in JS.
Wow.
Because, well, I guess A, why not? But then also, eventually I hope to self-host one day where it can compile itself, which leads to many interesting opportunities. But yeah, there's some experiments like profile guide optimization, where you add instrumentation to your WASM once you compile it once, log a bunch of extra debug things, and you can use that to optimize. Or like since you control the whole engine, you can do some interesting dev tools things, like say like a flame graph, which is pretty cool. But like say there's a JS benchmark, which is like an old V8 one, but you can have a live flame graph running in real time, which is very useful for if a benchmark takes like 10 minutes. But it just allows so many opportunities which you usually couldn't do, which like, because you control the entire stack. I have one dependency and it's a JS parser because just not insane enough to do that myself. But yeah, it leads for many interesting opportunities, like mostly using JS where you can't usually or can't well, like say embedded, which there's some stuff which you can do, but has questionable performance. But with this, it's as if you're writing it in C, essentially. Like, that's the hope. Or like better cold starts with edge runtimes. Like, say you're using JS with like AWS Lambda or something like that, instead of having to like wait for an entire JIT to start. If you compile in advance ahead of time, it's as if you wrote it natively. Or say you don't want to use JITs because you're like paranoid about security. Instead of having to use a usually quite slow interpreter, you can just compile ahead of time.
I've got a question.
Sure.
How do you get around previous attempts that have like failed because of like, having to profile a code or just run it to get any kind of type inference, like a JIT pass before you ahead of time? How are you doing dynamic type inference basically?
Yeah, so I guess like I have a few different solutions because I'm not trying to hedge my bet on one. One is the profile gun optimization, and another is it has too many things, I forget to show things. But if you write, say, like TypeScript, like say you had no type inferring, with this you would have no clue what A and B are if you didn't have these types. So say you might have to check for like string concatenation if you weren't like smart enough to infer. But you can just give it TypeScript natively, and it will use those types to optimize the actual output, which can be very nice for some optimizations because it's still quite a young project, so it doesn't have all the fancy like analyze every single type to its possibility. So for now, it's a nice like stopgap. Any other questions?
Thank you very much. Cool stuff.